This lesson is on angle measures and angle bisectors. Our essential question is, how is measuring an angle similar to and different from measuring a line segment? The standard is GCO A1 to know the precise definition of angle based on the undefined notions of distance around a circular arc. Here's our vocabulary words. Our first word is angle. An angle consists of two different rays that have the same initial point. So remember, a ray has an initial point and then the line has an arrowhead that shows that it goes on forever and ever. When you have two rays together, as you can see over here, this is one ray and this is the second ray. And where these two rays meet, they create an angle. Sides of an angle. In an angle, the rays are called the sides of an angle. Vertex of an angle. In an angle, the initial point is the vertex of the angle. In this case over here, this point right here, that's our initial point. That's where the two rays meet. It is called the vertex of an angle. Congruent angles. Congruent angles are the angles that have the same measure. Measure of an angle. The measure of angle AOB is equal to the absolute value of the difference between the real number of ray OA and ray OB. Usually when we're talking about the measure of an angle, you'll see it written like this. Measure of angle. In this case, we're looking at AOB. So measure of angle AOB. An acute angle is an angle that measures between 0 and 90 degrees. Right angle. A right angle is an angle that measures 90 degrees exactly. Obtuse angle. An obtuse angle is an angle that measures between 90 and 180 degrees. Straight angle. A straight angle is an angle that measures exactly 180 degrees. Angle bisector. An angle bisector is a ray that divides an angle into two adjacent angles that are congruent. Example 1, naming angles. In this example, we are to name the angles in the figure. Now, when you're naming angles, one thing that is important to know is where your vertex of your angle is. That will always be your middle letter. And usually when you name angles, you have 3 letters, with the middle one being the vertex. If we were looking here at this angle from K to L to J, we can say that one of its names is angle JLK, or we can go the other way and we can go angle KLJ. Notice in both of these names, the L, which is my vertex of my angle, is in the center or is the middle letter. The other angle we have goes this way, and one way we can name it is if we go MLK, or we can go the other way and say angle KLM. Again, vertex is at the center of the angle, so we're looking at this angle right here. The last angle that we have is basically a straight line, and so we can write it as angle JLM, or write it the other way as angle MLJ. Alright, checkpoint problems number 1 and 2 are yours. In both of these problems, it is asking you to write 2 names for the angle. So give me 2 names for problem number 1 and 2 names for problem number 2. Postulate 4, angle addition postulate. If point P is in the interior of angle RST, so angle RST is right here, and point P is inside angle RST, then the measure of angle RSP, which is this angle over here, RSP, plus the measure of angle PST, which is this angle over here, is equal to the measure of angle RST, which means that if I take this angle and add it to this angle, I get this entire red angle over here. Example number 2, calculating angle measures. Lawn care. A lawn is watered by a sprinkler that has 2 fixed spray heads that each spray water in a fan shape. The angle that determines each of the fan shapes is 120 degrees. The shaded area in the diagram shows where the 2 fan shapes overlap. Find the measure of angle 2. Well, I know that the sprinkler head, if I'm looking at the sprinkler head, which is number 1, it actually goes all the way over here and then overlaps with sprinkler head number 3, so that this shaded region is the region where the two sprinklers overlap. So I know that the measure of angle 1 plus the measure of angle 2 is 120 degrees. That's what it says over here. Now I'm given the measure of angle 1, that's 30 degrees. I know that the measure of angle 1 plus the measure of angle 2 is 120 degrees. I can solve for the measure of angle 2 by subtracting 30 on each side, and 120 minus 30 gives me 90 degrees. So the measure of angle 2 is 90 degrees. Problems number 3 and 4 are yours. In both of these problems, we are to use the angle addition postulate to find the measures of the angle. So for checkpoint problem number 3, find the measure of angle ABC. And for checkpoint problem number 4, find the measure of angle HLK. I'll give you a hint. This little square box over here means that this HLJ is 90 degrees. Example 3, dividing an angle measure in half. Ray RT is the angle bisector of angle QRS. Given that the measure of QRS is 90 degrees, what is the measure of angle QRT and angle TRS? Well, we know that an angle bisector divides an angle into two congruent angles, or two equal angles, each of which has half the measure of the original angle. So I know that the measure of QRT, which is this angle here, is congruent to this angle over here, TRS. The measure of QRT is equal to the measure of TRS. And I know that it's divided in half, so its original angle is 90 degrees divided by 2. Measure of QRT and the measure of TRS is 45 degrees. Alright, checkpoint problems number 3 and 4 are yours. In both of these problems, Ray EG is the angle bisector of angle DEF. Find the two angle measures not given in the diagram. I'll give you a hint. In problem number 3, it's GEF that's 52 degrees, so it's only this angle over here. You need to find this angle over here. And then in problem number 4, you'll notice that this angle measure goes all the way across. That means that the measure of angle DEF, that entire angle, is 64 degrees. You need to find what each one of these inside angles are. Alright, example number 4, finding the measures of an angle. In the diagram, Ray KM bisects angle JKL. The measures of the two congruent angles are 2x plus 7 and 4x minus 41. Find the measure of angle JKM and angle MKL. Well, we are told that KM bisects the angle JKL, which means that this angle over here, JKM, is equal to this angle over here, MKL. So measure of JKM is equal to the measure of angle MKL because they're congruent. I know that the measure of JKM is 2x plus 7. I also know that the measure of MKL is 4x minus 41. Now from here, all I'm doing is solving an equation. First step I will do is add 41 to both sides, so plus 41 over here, plus 41 over here. It says add 41. And I'm left with 2x over here. 7 plus 41 is 48. And on the right side, I'm left with 4x. Next step, I'm going to subtract 2x on both sides. And on the left side, I'm left with 48. 4x minus 2x is 2x. Finally, isolate x by dividing both sides by 2, and 48 divided by 2 is 24. So our value for x is 24. Once I find the value for x, the last step is to find the measures of angle JKM and angle MKL. In order to find the measure of the angle, I'm going to substitute the value that I found for x, which is 24, and I just need to substitute it into one of the angles because I know that 2x plus 7 is equal to 4x minus 41 because the angle is bisected. I just need to find one of the angles and then the other angle will have the same measure. So I'm going to choose this 2x plus 7. Where x goes, I'm going to substitute 24 in there, and then I'm going to simplify. 24 times 2 is 48. 48 plus 7 is 55. Each of the congruent angles has a measure of 55 degrees. Alright, checkpoint problem number 5 and 6 are yours. We are given that Ray BD is the